Welcome to the solution guide for the practice test for test number 3. So what I'll do is I'll break up the solution into 4 different videos, one for each problem. So obviously there's 4 problems here, so here's the first one. So you're asked to consider the following pair of nonlinear equations. Hopefully you can identify the first one, which I'll label as 1, as a circle. That's because you have 2 squared terms that are positive and equal coefficients. In the second one, hopefully identify that's a hyperbola because 2 squared terms with 1 being negative. Okay. And we'll leave these labels 1 and 2 for the equations there. So we'll provide a Euclidean definition. So for a circle, that should be pretty easy. Set of all points equidistant from a fixed point. For number 2, for the hyperbola, the Euclidean definition should be the following: the set of all points in which the distances from 2 fixed points. Actually, let me rephrase that. In which the difference of the distances, my apologies, in which the difference of the distances from 2 fixed points is a constant. For part C, explain how the intersection of a plane with a double nap cone will result in each conic section in part A. So, for the circle, a double nap cone and make a cut like that, so cut parallel to the bases, that's how you form a circle. For the hyperbola, number 2, if I make a cut like that, cut perpendicular to the bases, clearly I would be getting myself hyperbola that way. So A, B, and C are kind of just like more theoretical, just understanding what's a circle, what's a hyperbola, defining it, explaining how it's formed. D, E, and F is more the math you have to do. So for part 3, you have to write each equation in standard form. Well, for a circle, and I will give you a formula sheet that will have all the formulas for all the conic sections, but I'm not going to label it. So you gotta know which one's which. Standard equation for a circle is this. And of course for hyperbola, depending on how it's going to open, now I know it's going to open along the x-axis because x squared comes first. So that's why I went with x minus h squared over a squared as being the positive fraction instead of the other way around. So we'll start with 1, the circle. The equation was x squared plus y squared minus 12x plus 32. So I'm going to group x squared. Okay, I wonder what's going on here. Here we go. X squared minus 12x plus y squared equals negative 32. So give it a little bit of space here. Now remember, you want to take half of the linear coefficient and square it. So changing color so you can see what I'm doing. Half of negative 12 is negative 6. That squared is 36. it's going to have 36 that side. And y squared is just y squared. There's really no y or any reason to complete the square for that one. So there's no linear term for y. So I can just keep going. That's x minus 6 squared. If I factor all that, plus y squared equals 4. Then divide both sides by 4. So you have x minus 6. Actually, I'm losing my mind. That's why I shouldn't do this on a Friday early evening. That's it. That's your circle. Because non-ellipse, so we can leave it like that. For number 2, for the hyperbola, x squared minus y squared minus 16 equals 0. So x squared minus y squared equals 16. Now this, because I do want to divide both sides by 16, because I need 1 on the right side. So it's x squared of 16 minus y squared of 16 equals 1. We have that in standard form. Now for part E. Graph each equation, state all the important characteristics. So clearly number 1 is a circle, so we need to know the center and the radius. Well, the center should be obvious. 6, and there's nothing connected to y, so 6 comma 0. And radius is easy, just plain old 2. So I locate my center right there. And radius of 2. There we go. So that's actually a pretty good looking circle. Alright, number 2. For hyperbola, we want to know the center. We want to know the vertices. We want to know the foci. And we want to know the asymptotes. If the center is at 0, 0, we'll definitely want to know the asymptotes. Because it's kind of hard to find if the center for the hyperbola is not at 0, 0. I won't ask you to find the asymptotes for that. But one other thing I want to mention is that when I ask to state all the important characteristics, I'm not going to tell you what are the important characteristics. You need to know that. So if you ask me during a test, like, okay, well, I have an ellipse, I don't know what the important characteristics are, I'm just going to shrug my shoulders. You need to know that. So obviously from part A, we know what conic sections we have, so now we find the important characteristics for it. The center obviously is at 6, 0. I'm sorry, 0, 0. That was for the circle. The center for the hyperbola is at 0, 0 because I don't see an H or K. H comma K is 0, 0 because again, nothing's being subtracted x or y for the hyperbola. The vertices I know is going to be plus or minus 4 comma 0. That's because a squared equals 16 or a equals 4. Remember, that right there is going to be a squared. A squared is always going to be the denominator for the positive fraction for hyperbola. And so we're going to go 4 away from the center. So if I use a new color to graph my hyperbola, I know the center is right here. It's got to be 4 to the left and 4 to the right. The foci is going to be this. And here's the reason why. We know that b squared also equals 16. That's going to be b squared. And c squared equals a squared plus b squared. So it'll be 16 plus 16, which is 32. So c is going to equal root 32, or 4 root 2 if you simplify it. And we have to be 4 root 2 away from the center, so that's why it's going to be plus or minus 4 root 2. And that's going to be roughly between 5 and 6. So my foci will be here and there between -5 and -6 on the other side. And again, since b squared is 16, b is going to be 4. So I've now got enough to draw my rectangle. and then I could draw my hyperbola. And it has to open horizontally since the positive fraction contained x. Opens horizontally since that's positive. And then lastly, for my asymptotes, pretty easy. See how it goes up 4 and over 4, or it goes down 4 over 4. So plus or minus x. So that's the graph, and then of course our asymptotes, our foci was here and here. And of course those are the vertices. Okay, so that covers the graphing part. Then lastly, for part F, you're asked to find all points of intersection for the system equations algebraically. Well, by looking at it, we can see it crosses 1, so it looks like it crosses at 4, 0. But really, we just want to prove it algebraically. So here is the first equation, x squared plus y squared minus 12x plus 32 equals 0. X squared minus y squared minus 16 equals 0. We'll probably want to use elimination to solve this. So if I add both equations, see how those go away? So 2x squared minus 12x plus 16 equals 0. Factor out of 2. Keep factoring. X minus 4, x minus 2, so we get two answers. 2 or 4. Now clearly I know x equals 2 is not going to work because I don't see the hyperbola circle touching at a point where it x coordinates to. But just to prove it, let's plug back in to that equation. So 2 squared minus y squared minus 16 equals 0. Negative y squared minus 12 equals 0. So negative 12 equals y squared, which will result in an imaginary answer. So we got to get rid of that one. But here, 4 squared minus y squared minus 16 equals 0. Again, I'm plugging into the second equation since that's a little bit easier to do. You get negative y squared equals 0. Of course, y equals 0. That's okay. So the answer for that one's going to be 4 comma 0. So we proved that algebraically, and graphically it makes sense. So I'll design number 1 in a very similar way, unless you guys don't like it that way. But this kind of covers a lot of things. Think about part F covers 9.7. Part E covers pretty much 9.6. D kind of does the same thing, 9.6. And then A, B, and C kind of wraps it all up, covering 9.2 through 9.5. So, expect number 1 to be like this. Of course, I'll probably do maybe 2 different conic sections. Maybe I'll do a parabola with an ellipse or an ellipse with hyperbola. There could be a variety of things you could see here. Okay, so that finishes the solution for number 1 of the practice test.